Welcome to Intrigue Scale Models. I'm Jason, your host, and I do models. How is everyone doing today? We are doing more electronics fun with Make Electronics Experiment 10, transistor switching. Alright, let's go to the overhead. I'll put my keyboard up because I don't need that. And it is, now that you've seen the behavior of capacitor, I'm going to move forward on another fundamental component of the transistor. After you learn how that works, you'll see how capacitors and transistors are used together. So I can get rid of my bookmark, and I can get my awesome ProTech Trader supplies for experiments 1 through 11. We're on 10. Seems like I have more stuff than 1 through 11, but we're going to do this. So we need our breadboard. And I am going to use this breadboard right here because I'll just pull this thing for later off. I'll use this breadboard. We have hookup wires and all that stuff, so we need a 2N 222 transistor and then some resistors and a trim and a potentiometer and a generic LED. So transistors, I will show you what a transistor looks like here. This should be the transistor. We'll see if how this looks under here, right there, and I will try to focus it. And really, autofocus is the way to go. So that is the transistor. It's hard to see. So there it says 2N222A. That is a transistor. We needed just one of those. Okay, we got a little bit extra here. And then we need our potentiometer. We all know what that looks like from earlier experiments. If you haven't checked out the earlier experiments, check those out. There's our potentiometer, just one of those. Oh, it's a trimmer potentiometer, not this one. That's my fault. Let me show you guys. I don't know if I showed you the trimmer potentiometer in one of our Make Electronics series. It is 500K. Let's take a look at what this looks like. Here's how small it is in my hands. Let's see if we can get a picture of it underneath there. There we go. Let's see if we can get that in better focus. There we go. So that's what a trimmer pot looks like. I can stand it up to show you the top. There's what the top looks like. So that's our trimmer pot, and we have our transistor. Now we need our 2 resistors. We need a 470 ohm resistor. Been using a lot of 470s. There's what a 470 looks like. I don't know if you're going to be able to see the bands on there. Now, you know what I need? I need more light. I think that's the problem. It seems like with OBS, everything looks fine in real life, but through the use of the software, that light's not going to work on me. And I have seemed to have misplaced other light. Okay, well, let's see if I can change the white balance on it. No. I can change the brightness. I did nothing. Okay, well that did nothing. So we really can't see what bands are on that resistor because it's so dark. Need to get more light on that. So, well, just you have to take my word that it is. Well, let's just look at the color code and check to see what it is. 470 would be yellow, purple, and then 10 would be brown. So yellow, purple, brown. And that appears to be what we have on that resistor. So enough time wasting. We need a 1 meg ohm resistor. This is my first time using this microscope camera on the computer, so you have to bear with me if it has issues. It's my son's for school, and then I was like, oh, it hooks up to the computer, that's cool. But I can't hook it up with all my cameras. I only can have 3 cameras for some reason. So I have this one, the webcam, and my main camera, and then I switch between this one and the DSLR. So this one is brown, black, green, 1 meg. See, you're not going to see that either. So I'm just going to get that off of there. Okay, so that's that. We got the breadboard and a generic LED. Oh, let's use a green one today. Just grab a green LED right there. We'll put it right there. It's green. Alright, we'll just put it up there, and then we'll put our kit up here. And what are we doing here? So we have this. We will turn on our Siglent SPD 3303XE. That is our it's one of our test equipments here, our power supply. It's our power supply. We're also going to be using the Siglent SDM 3045X, the 4.5 digit multimeter. Looks like we need 9 volts. We'll use channel 1. Turn that on when ready. Let me bring up the meter. Okay, so the meter is up and going. Oh, it's going to give me a bunch of garbage. Yeah, when you're setting these up, do not ever click on the wrong device if you have a bunch of Siglent stuff picked up in there. Yeah, it gets real weird. Okay, so I just picked up a hum in my... No, it didn't go away. That's weird. Picked up a hum in my feedback. Hopefully the recording's okay. Alright, so we have that. We have our meter. So we're going to do the finger test to show you the most widely common use of oscilloscopes of all time. It was introduced by Motorola in 1962 and has been in production ever since in one form or another. Because the Motorola's patent on the E2N222 ran out long ago, any company can manufacture their own version. So we got essential transistors on page 49, although we already went through that. Okay, so plug your transistor into the breadboard with your 470 ohm resistor. So I have my 470 ohm resistor and my transistor. So it looks like we're going to plug this into here like this. Just need to splay the legs a little bit here. Okay, so we're going to plug this in there like so. And then we're going to take, let's get the test equipment off of there. So I'm going to move this book up here. I'm going to bring down this because I'm going to show you what to do now. We don't really need the book. And we're going to come in here and brighten the image up a little bit. So we have this transistor, and then we have our LED, and our positive is going to, oh, I didn't explain this to you. This is emitter base collector. And if you have a hard time knowing what all your transistors do, this is a transistor tester. It's very cheap. It's just, you plug it in there and it will tell you what each of your legs are. It doesn't take but a minute. This should tell me it's a emitter base collector. It tells me some other information, so we know that that is our emitter base collector. So we're going to plug this back into our board here. Then it looks like we're plugging the positive lead into the emitter of our LED into the emitter, and then we're going to ground with the 470K resistor. So we're going to plug into this side of it and into ground here. All my ground and power are connected through, and I have it all powered up here. And then it looks like we're going to take two pieces of jumper wire. Alright, let's get two pieces of jumper wire here. So we want a green and a yellow. So we don't need anything real long here. We're just gonna, this is just, I'm not sure what gauge this is. It doesn't tell me, but it's about 0.8 millimeters in diameter, and it's super cheap. I use it for this jumper wire stuff. I have some super stuff, but I'm going to use this wire stripper from Kimpex. It works great. You just stick it in there. It auto adjusts to strip the wire. So I have it set for a depth. You can set the amount it strips off. I have it set for breadboard wires, and it does, you know, the wire's pretty good. So we need a green going to the base. Oh, it looks like we also need a jumper from the collector to power. Collector to power here. That's not the right one. That's off camera. To the collector. This is getting to be a long video. I'm having a day. I'm trying to get this for you guys. An alarm is going to go off in any minute now. You know the alarm, it comes through my videos, and I'm moving away from the microphone because it is going to go off. If you guys have been watching the channel and you hear that alarm go off, that is for my medicine. So this one is going to go to the positive rail. Okay, now, well, that is one funky looking resistor. So we are going to add 9 volts here. I'm going to turn the amperage down because I was doing some put it to 50 milliamps because we don't need that much for this circuit. I was testing some other stuff earlier. So we're going to turn this on and nothing happens. Oh no, my circuit doesn't work. What do I do? But if I touch these two, I thought it was going to be a touch through my finger. Oh, it does. It does light a little bit if I... Okay, so let's dim this down a little bit, and I'll show you. I have to dim that down a little bit, and if I touch the two, it really lights. But if I do, so if I grab these two, you can see it has a faint glow. It's hard to see. I don't know. I mean, you can see it a little bit. I pulse it. If I put them close together and I touch my finger, yeah, so you can see it glow a little bit, but not a lot. So, see, it lights all the way. Yeah, so that is how the transistor, you can use it as a switch to light up an LED. Now, let's see what's going on here. So, if I have a resistance of 1 megohm, that is, that is dimly lighting the light, so I'm going to use this 1 meg resistor here. And I'm going to connect this 1 meg resistor from the base. Going a little bit off book, but I think I know where they're going with this. So I'm going to do that like that. And I'm going to leave that plugged into the positive, and I'm going to get my current probe and my black probe. Black probe here, plug this in, and I'm going to switch myself to the DC current. Okay, we're in DC current. I have the current probe. So what I'm going to do is I'm going to clip on to this resistor, and then I'm going to clip on to this end right here. And as you can see, the light lights dimly like it did with my body, and we are drawing 5.88 microamps. Now, let's see how much current is being drawn with the kitbashing, because I only have one on camera here, and we'll look at the multiplication factor of a transistor. So we'll get this kitbashing here, lighten it up a little bit, where you can still see the LED, but okay, you can still see the LED. So I'm going to pull out this resistor and stick it over here. And I'm going to put this green wire into the negative, and I'm going to turn this to, we'll do 200 milliamps, and we will connect the positive to the resistor, and this to this, and our LED lights dimly, and you can see I am drawing 1.48 milliamps through the LED, but the base to emitter is only doing 5.6 microamps. So with a very small current through the transistor, through the base emitter, I can get a higher current from the collector to the emitter. And that's basically how this circuit works. Now, if I were to take out this right here, so I am drawing 52 microamps, and I'm now getting 13 milliamps through the LED. So as I got rid of the resistor and I'm just going straight to ground using the resistance of the leads of my meter, I'm drawing 53 microamps, and I am now passing 13 milliamps through the LED. So that is how a transistor can be used as a switch to drive higher current loads. So let's say, for example, like in my logic series, let me put this back on voltage before I blow something up. Okay, so like say for my logic series, I wanted to run something that drew a lot of current. And a TTL chip can't give a lot of current, it can't source a lot of current, can't sink too much current either, but what I can do is I can use the TTL chip to turn on a transistor that uses very little current to drive a much larger current load in my circuit. So effectively, it's a switch that you can multiply the current, so it has that multiplication effect. So that is that. We're going to turn off the output of the power supply. So, well, definitely said don't use two hands. Yeah, well, I did that. Don't do that, guys. Okay, so it talks about the finger test. It talks about the current flow in and out, small amount of current. So talks about different types. So I'm going to let you guys do the rest of the transistors. It goes into NPN and PNP transistors. What we used was an NPN transistor. And the next experiment we're going to do is experiment 11, light and sound. So you can see what's needed there. Let's get rid of the meter. And so we're going to need a bunch of capacitors, a bunch of resistors. So I'll try to pull this out ahead of time, and the speaker. Check that out. So that's going to do it for this video, guys. You can check me out on these social media links. Also support me on Patreon.